Welcome to our Rotations for Organic Grain Cropping Systems module.
This module was authored by Christine Moncada, Constance Carlson, Gigi DiGiacomo, and Craig Schaefer of the University of Minnesota in 2017 and was updated in 2026. Narrated by Constance Carlson, with additional narration generated using the AI voice of Hannah from ElevenLabs.
Organic farmers are required to utilize rotations under the National Organic Program rules. Let's start with how rotation is defined under NOP regulations.
We will then cover rotation benefits, NOP standards, planning rotations, and rotation examples. On this slide, we show a graphic of a cycle labeled with years 1 through 4 to represent a 4-year rotation.
As defined by the NOP, a rotation is the alternating of annual crops grown on a specific field in a planned pattern or sequence in successive crop years. This means that crops of the same species or family are not grown repeatedly without interruption on the same field. The opposite of a rotation is continuous cropping. One example of this is growing corn in the same field for more than one season. This would not be allowed in organic systems. Continuous cropping does not provide rotation benefits. We will discuss this later in the module. We know that growing the same crop in the same field over and over is not a rotation. However, rotations can vary in length and diversity. So that leaves many options of crops that can be included in a rotation and the number of years that a rotation can span. Rotations can also vary by region based on the crops that are adapted to that area.
In this simple pie chart with circular arrows, we show a 3-year rotation of corn, soybean, and wheat.
As rotation length and crop diversity increases, rotation benefits also increase. What exactly are these benefits? In this section, we will describe the benefits of rotation in more detail.
Soil quality, soil fertility, weed management, and disease and insect management are some of the biggest challenges organic farmers face.
Diverse rotations can have an impact on many of these issues. Diverse rotations that include perennials and cover crops can improve soil quality by contributing to soil organic matter. Crops that overwinter can also protect soil from erosion.
This image shows the spring vegetative growth of a rye cover crop protecting the soil.
An organic research study conducted in Minnesota compared 2-year and 4-year rotations. In this chart, you can see the difference in the percentage of large soil aggregates, an indicator of soil quality, in 2 different organic rotations. The longer 4-year rotation with corn, soybean, oat, and alfalfa had a larger percentage of aggregates compared to a 2-year corn, soybean rotation.
The bar graph shows the 2-year rotation had over 30% large aggregates, while the 4-year rotation had almost 40% large aggregates.
Larger amounts of aggregates may be an indicator of greater soil quality. Legumes, especially alfalfa, can supply nitrogen to subsequent crops in the rotation. Corn grown after alfalfa will generally not need additional nitrogen fertilizer. Take a close look at these 2 research plots in Minnesota. The corn looks quite different in each plot, doesn't it? The corn in plot 1 is green and healthy looking, while the corn in plot 2 is showing signs of nutritional deficiencies. Neither plot was fertilized, but the corn in plot 1 was grown after a year of alfalfa, while the corn in plot 2 was grown after wheat.
The image shows two side-by-side corn plots. The corn in plot 1 is tall and dark green. The corn in plot 2 is shorter and has yellowish leaves.
The rotation effect shows that yields in rotations are greater than those in continuous cropping, even when the factors such as increased nitrogen due to legumes are taken into consideration. In other words, if you just rotate crops, whether they add nitrogen or not, you get a yield benefit. The exact reason why is unknown. Another benefit of diverse rotations that is particularly helpful in organic farming is weed management. By diversifying the types of crops planted, rotations can be used to break up weed cycles. Having mainly row crops, such as corn and soybean, will lead to weeds adapted to that system because they have similar planting dates and mechanical weed control operations. Examples of weeds that are prone to becoming problematic in corn and soybean are pigweeds and foxtails.
We show a picture of redroot pigweed with its green flower inflorescence.
Cool season small grains such as wheat, barley, and oats may combat the weeds that thrive in row crops. They can crowd out warm season weeds, and many of the weeds that do grow get chopped down during harvest before they can set seed. Can you see any annual weeds in this field of organic barley?
The image shows a vast field of mature barley that is gold-colored. No signs of any other plant species are apparent.
Perennials such as alfalfa provide continuous soil cover to inhibit weeds from germinating. They can be particularly effective in managing annual weeds that plague row crops. Harvesting forage mows weeds several times a season, which can prevent seed production of annual weeds and deplete the root reserves of perennial weeds. In a long-term study conducted at Lamberton, Minnesota, organic rotations that included a small grain and alfalfa had lower amounts of foxtail seeds in the weed seed bank as compared to a corn-soybean rotation.
We show a bar graph of foxtail seeds per core in a 2-year rotation and a 4-year rotation. The 4-year rotation included oats, alfalfa, corn, and soybean, while the 2-year rotation was just corn and soybean. The 2-year rotation had over 40 foxtail seeds per soil core, while the 4-year rotation had about 30 foxtail seeds per core. This unpublished data is from Har et al., 2008.
Organic farmers can't use synthetic pesticides to control disease and insects, so rotation can be a valuable tool in pest management. Longer rotations can break up disease and insect cycles. While rotations may not eliminate disease pathogens and insect pests, a proper rotation can decrease some pests to sustainable and less damaging levels. This is because after a long enough time without a host, many pest populations decline.
In this image, we show a close-up of a European corn borer larvae on a corn leaf. The more soybean is grown in a field, the more prevalent soybean cyst nematode becomes.
In research conducted in organic fields in Minnesota, the number of soybean cyst nematode eggs was examined in different lengths of rotation. With 500 eggs per 100 cubic centimeters of soil as the threshold for damage, it was found that soybean cyst nematode reached damaging levels when soybean was grown every other or every 2 years in rotations.
We display a data table of rotation length and soybean cyst nematode eggs per 100 cubic centimeters of soil. When soybean was grown every 2 years, 3,657 eggs per 100 cubic centimeters of soil were found. When soybean was grown every 3 years, 1,306 eggs were found. When soybean was grown every 4 years, 496 eggs were found. When no soybean was grown, no eggs were found. This data is from Chen et al., 2012.
Research has been done on several pests and how long they persist in fields without their hosts. Here are a few examples where insects or disease incidence can be reduced by lengthening the time between the susceptible crops in the rotation.
Here we show a table of crop, pest, and the length of the rotation period to control that pest. For corn rootworm, the rotation period between corn crops needed to reduce that pest is 1 to 2 years. For soybean cyst nematode, the rotation period needed between soybean crops is 3 to 5 years. For scab and small grains, the rotation period needed between small grain crops is 2 to 3 years.
For more on pest management, please watch our modules on individual crops. Not all insects and diseases can be managed with rotation. For example, soybean rust travels via the wind to infect crops.
We show a map of the U.S. with arrows indicating the pathways the wind-borne rust spores travel. They travel from the southern states up to the northern states. The main pathway is shown from Texas up to the Midwest. A smaller pathway is shown from Louisiana to the northeast.
The distances rust travels can be quite extensive. Some pests, such as lesion nematode, infect a wide range of hosts and are ubiquitous in the environment. Some disease pathogens, such as Sclerotinia, and also some nematodes, have dormancy structures that persist for many years. Some disease organisms, like some types of Pythium, don't need hosts and survive in the soil on their own. Some benefits of diverse rotations are unrelated to production. Diverse rotations can spread out financial risk. If one crop fails in a given year, perhaps due to an insect or disease pest, there will be other crops in other fields that provide income. Crops can experience price swings depending on markets. If the price crashes for one crop, having other crops can lessen the loss. When a farm has diversified rotations across fields, this also diversifies field operations. Different crops have different times for planting, weed control, and harvesting. This can help spread out work over time and can reduce the risk of not having labor to perform field operations when they most need to be done. The National Organic Program emphasizes diverse rotations because it is one of the strongest tools to manage many concerns.
We show images of corn, alfalfa, wheat, and soybean, which are examples of good crops for organic rotations in the Midwest.
The NOP has recommendations for what to incorporate in organic rotations. These include legumes to add nitrogen, a diversity of plant species and plant families to break up pest cycles, crops with different rooting systems to improve soil quality, crops with different pest pressures to reduce pest proliferation, and green manures and cover crops to suppress weeds. Once you are certified, there are National Organic Program rotation standards that must be followed. For field cropping systems, generally there must be a minimum of 3 different crops within a 5-year period for the same field. The same annual crop can't be grown 2 years in a row in the same field. There are a few exceptions to the rule. A rotation can have only 2 crops if one of the crops is a perennial that is grown for more than 2 years. For example, alfalfa grown for 3 years, followed by a year of corn. The second exception is if 2 annual crops are grown with a cover crop in between. For example, a corn and soybean rotation with oat and winter rye cover crops. However, this example is not at all diverse and carries more risk. Why might this be so? Despite the inclusion of cover crops, this ultimately is a corn-soybean rotation with similar hazards as we discussed earlier in this module. Additionally, a certifying agency may not be amenable to the least diverse cropping systems. Now that you know benefits and standards for rotations, how will you plan your rotation? Let's go over what to consider when planning your rotation and take a look at why farmers' rotations can differ from one another.
These considerations include markets, your operation, crop sequence, and flexibility.
Every crop is not equally profitable and every crop is not equally beneficial to soil health. For example, alfalfa has many soil building properties, but it is generally not as profitable as corn. Producers need to balance profit with potential rotation benefits, such as soil health, to find the best crop rotation for their operations. The number one thing to consider when adding a new crop to your rotation is whether you have a market for that crop. It may depend on your location. For example, we often recommend alfalfa in rotations, but if a producer doesn't have livestock or a nearby market for hay, it can be difficult to justify including alfalfa. Other less commonly grown organic grain crops, such as winter rye, have very small markets where it is difficult to find buyers. Not all crops will grow successfully on your farm. Small grains are beneficial to include in row crop rotations, but these crops may not work for some producers who are located in areas that have serious disease. An example is how regions with hot and humid conditions can have greater incidence of Fusarium head blight, which can cause crop failure. Or, some crops may not be adapted to your specific conditions, such as poorly drained soils.
In this picture, we show a close-up of the seed head of a wheat plant that was infected with Fusarium head blight, also called scab. Many of the developing seeds are brown instead of green due to the disease.
Another critical consideration for new crops is whether you have the proper planting and harvesting equipment, or if custom work is available for their production.
For example, equipment to cut alfalfa, as shown in this image, is an example of specialized equipment.
Some crops, such as corn, have high fertility requirements. Without alfalfa in the rotation, they certainly will require a source of nutrients, such as manure, compost, or another amendment. Do you have an economical or nearby source?
Here we show manure being applied to an organic field by a tractor with manure tanks.
The order of crops in your rotation is important, and some crop sequences are more optimal than others. Here are some general rules when planning your crop rotation. Crops that are susceptible to the same diseases should not be grown after each other. For example, soybean should not be followed with field beans, or barley would not be followed by wheat because they are susceptible to the same diseases. For more information on specific diseases and their hosts, please visit your local Extension Service website. Crops that fix nitrogen, such as alfalfa, should be followed by crops that can get the most use of that nitrogen, such as corn. Weed pressure may build in crops that don't compete well with weeds, so less competitive crops, such as flax, should alternate with competitive crops, such as a small grain. Asking other farmers who have grown a specific crop can help you gauge how competitive a crop is. Just like all farmers, organic farmers will need to be flexible in their rotations due to weather, markets, and disease forecasts. You may have decided your rotation long in advance, but plans sometimes need to be changed.
Here we show extensive flooding of a field and an adjacent road, a great example of an event that can change planting plans.
What happens if you need to make changes? Your organic system plan indicates what you intend your rotation to be, but of course, you are allowed to make some changes when necessary. Changes still need to adhere to NOP rules for rotations. For example, corn can't follow corn. It is very important to notify your certifier of changes prior to making them. Keep track of any rotation changes in all records, including your OSP. In this section, We will focus on rotations with common field crops in our region, including corn, soybean, small grains, forages, and several other crops. Rotations can vary in length from 3 to 5 years, or even longer.
We will start with one example of a 3-year rotation. Year 1 is corn, Year 2 is soybean, and Year 3 is a small grain.
In this rotation, we have corn, soybean, and a small grain, which could be either oat, barley, or spring wheat. This is a common rotation in regions without livestock where alfalfa or hay markets are not present. Organic farmers will often underseed the small grain with red clover. The red clover is terminated in the fall or spring before the next crop. The red clover will supply some nitrogen, but supplemental compost or manure will be necessary for the corn crop. This rotation is less diverse, and some of the benefits of a longer rotation will be lost.
Here is another 3-year rotation example. Year 1 is corn, Year 2 is soybean, and Year 3 is field pea.
This rotation is similar to the previous one and may provide an alternative in regions where small grains are disease-prone. Field peas, like small grains, are harvested early and allow ample time for a fall-planted cover crop.
Our next example is a 4-year rotation. Year 1 is corn, Year 2 is soybean, Year 3 is a small grain like oat, barley, or spring wheat, and Year 4 is alfalfa.
This 4-year rotation is a good one for producers who don't have access to manure, but it also requires them to have a market for the alfalfa hay. The alfalfa is underseeded with the small grain in the spring. Perennial legume crops such as alfalfa provide many soil benefits and can help control weeds.
Here we show an example of a 5-year rotation. Year 1 is corn, Year 2 is soybean, Year 3 is a small grain, and Years 4 and 5 are alfalfa.
This is the same rotation as the previous slide, but with an additional year of alfalfa. 2 years of alfalfa in most cases will provide all the nitrogen necessary for corn.
Here is another 5-year rotation. Year 1 is corn, Year 2 is soybean, Year 3 is corn, Year 4 is a small grain, and Year 5 is alfalfa.
This 5-year rotation provides another high-value crop by adding an extra year of corn. The corn in Year 3 will need supplemental fertilizer for good yields. One negative to this rotation is that 3 years of row crops can lead to pest management problems, especially with weeds. Consider the rotation examples that we present here to be templates you can adjust to your own needs and experiences. Let's look at a real-world example. An organic farmer in Lac-qui-Parle County in western Minnesota usually has a 3 to 4 year rotation of corn, soybean, and small grains, underseeded with red clover.
We show a picture of a small grain underseeded with a legume. The small legume seedlings are between the rows of the taller small grain plants.
However, when a field needs soil building or better weed management, he will add 2 or 3 years of alfalfa to that rotation. Thus, his rotation is sometimes as long as 6 years.
This 6-year rotation is corn, soybean, small grain, and then 3 years of alfalfa.
So far, we have focused on rotations for a single field, but farms have multiple fields, which can make planning rotations for the whole farm more complex. Here is an example of a farm with 3 fields.
Field 1 has a 5-year rotation. Year 1 is corn, Year 2 is soybean, Year 3 is oat with alfalfa planted after oat harvest, and Years 4 and 5 are alfalfa. Field 2 has a 3-year rotation. Year 1 is wheat underseeded with red clover, Year 2 is corn, and Year 3 is soybean. Then the rotation starts over in Year 4 with oat underseeded with red clover, and Year 5 is corn. Field 3 has a 3-year rotation. Year 1 is soybean. Year 2, barley underseeded with red clover, and Year 3 is corn. Then the rotation starts over with soybean in Year 4, followed by wheat underseeded with red clover in Year 5.
Notice how the rotations are staggered, so that each field has a different crop in a given year. We've reached the end of our rotation module. We hope you have discovered some useful information to help in planning your own rotations.
This project is supported by the U.S. Department of Agriculture, National Institute of Food and Agriculture, Organic Transitions Program under Award Number 2013-5, 1106-2-1005. This project is supported by the U.S. Department of Agriculture, Agricultural Marketing Service, National Organic Program under the Transition to Organic Partnership Program, TOPP, in the Midwest region. Any opinions, findings, conclusions, or recommendations expressed in this publication are those of the authors and should not be construed to represent any official USDA or U.S. government determination or policy. The University of Minnesota shall provide equal access to and opportunity in its programs, facilities, and employment without regard to race, color, creed, religion, national origin, gender, age, marital status, familial status, disability, public assistance status, membership or activity in a local commission created for the purpose of dealing with discrimination, veteran status, sexual orientation, gender identity, or gender expression. For more information about this project, please see organicag.umn.edu, copyright 2026, Regents of the University of Minnesota. All rights reserved.